Okay, so example number 2, we want to solve this equation again by graphing. Now, if you ever see that there's no 0 on one of the sides, you have to make that happen by moving things over to the other side. So I'm going to start by writing 3m squared minus m, but instead of this minus 2 there, I'm going to add 2 on the left side so that I have a 0 on one of the sides. You cannot do a graphical solution until you have 0 on either the left side of your equal sign or the right side. So then what I'm going to do is go to my graphing calculator and I'm going to enter that in. So I'm going to have 3x squared instead minus x, and then instead of minus 2, because we brought it over, it became plus 2. We're going to change it to the standard window. So for you guys, it's zoom 6. So it gives me something like this. Okay, so what I can do is go second graph, and that gives me a few table of value points. So I know that I have 0, 2 as a point. Oops, wrong graph. 0, 2 would be here. I have 2, 12. A little off there. I'm just going to create a sketch. I'm going to do 1, 4 actually, because that's on the grid. 1, 4 should be here. And then I also have the point -1 and 6. Okay, so the reason I did that is I wanted to get a good sketch of what this looks like. Now, in this one, it does not touch your x-axis. There is no point of the graph that touches your x-axis, so there are actually no solutions. There's no answer to this question here. So if you quickly want to check if there's a solution, graph it. If it touches the x-axis, there is a solution. If it does not touch your x-axis, there are no solutions. Okay, so what's always important is to label your x and your y-axis and put numbers down. So you're going to see that it becomes very important for next year's diploma. So always label your graph. Etc. Example number 3. So again, we're going to start by putting this into our graphing calculator. They want to know the horizontal distance between the two towers. So where it touches the x-axis will be where the towers are, and we want to find the distance between them. So in our graphing calculator, we're going to go to y equals. We're going to put in the number that we see. Instead of our values, instead of our variable d, we're using x. Okay, and for this one, we can see that the vertex is at 112 and -12. So we can use that to figure out that our x values, so we know that the midpoint, the middle is going to be at 100. So let's make it go up to maybe 200. So I'm just going more than 100. So I'm going just doubling that value. And for y, we know that it's going to reach -12. So I'm going to go to -13, just slightly lower than that vertex point. And then when I graph it, this is a nice image because I see the x-intercepts and I see that vertex. But what's more important is the x-intercepts now in this part of the unit. So we're going to go second trace. We're going to go to number 2 for 0. You're going to go to the left bound, which is there. So you're going to move your left cursor until you get there. Press enter. Then you're going to move your right cursor until you get here. So that's the right bound, press enter, and then enter again, and you should find that the value of x is 30.7, because I'm rounding to the nearest tenth. So we know that x is equal to 30.7. Now we have our first x-intercept, but we also need the second x-intercept. So let's do that again. Second trace, number 2, you're going to move your cursor until you get here, which is your left bound, where y is negative, press enter, and then move your right cursor until you get there, where y is positive. Press enter and then enter again, and you should find that the point is 169.3. 169.3. And then because we want the horizontal distances, so what we're doing is we're sketching this right now. So I'm just going to do an approximation. Let's go up by 20s, 20, 40, 60, 80, 100, all the way to 200. Okay, and then our y value will go down by 2. So 2, 4, 6, 8. Actually, no, I want to go each unit by 2. So that'll be -2, -4, -6, -8, -10, -12, and that's good enough. Okay, so we know that there is an x-intercept approximately here and at 168.9, so there. And we know the graph is at 100 and -12 for the vertex, so I'm just using that to create my sketch. Okay, so create a nice sketch, always label your x and your y-axis, and then what we want to do to find the distance between these two values, you need to subtract them. So we're going to take 169.3 and subtract 30.7 in our calculator. So 169.3, so this is what you're doing, minus 30.7, we get 138.6, and that's in meters. Don't forget your units. Example number 4, what they're giving us is the equation of the axis of symmetry is x equals 0. So we know that there's that dotted line that cuts it straight down the middle at x equals 0. So dotted line, axis of symmetry. We know that one x-intercept is at -4, so I'm going to plot that. Now, this line means that there is the same distance on the left side as there is in the right side. So in order to find the other x-intercept, we just have to go 4 units in the other direction. So if I know that this is -4, then the other x-intercept will occur at +4. So that's it. Just by using the axis of symmetry, you can find that the other x-intercept is at +4. So you just do a reflection, change the sign of it, and it becomes the opposite. Our last question here, the product of two consecutive even integers is 224. So consecutive even integers, let's talk about that. X, we don't know what it is, so we're going to say that the x represents our first even integer. And then for it to be consecutive, an example would be 2 and 4. Those are consecutive even integers. So let's say this was x. Well, what do we have to do to x to get to 4? We would have to go x plus 2, and that would replace 4. So that's going to be our next consecutive. Consecutive just means one after the other. So for example, 6 and 8 are consecutive even integers. 10 and 12, consecutive even integers. So if this is x, we would have to go x plus 2 to get to 12. Okay, so they want the product of them. So we're going to take x and we're going to multiply it by x plus 2, and the answer of that, meaning the product, the multiplication of that, should equal 224. So whenever you're doing a word problem, you should never have it equaling 0 unless they tell you it. They're going to give you the answer, but what you have to do is first get rid of the brackets by distribution, and then you're going to move that 224 to the other side to get that 0 happening. So you won't have a 0 until you move things to the other side. So we're going to graphically do this and find out what the values are. So in our graphing calculator, you're putting x squared plus 2x minus 224. Change your window. So I'm going to use my window as -20, +20. So it takes practice to get your window. So I work with the numbers, I look at them. I usually look at the last number because I have to find numbers that multiply to it and add up to 224. So I'm kind of using that little hint. And then for my y, I use the standard -10 to +10 and scale of 1. So I graphed it. Now I don't see the vertex, which really doesn't matter in this lesson and going forward, because all I care about is where the graph touches the x-axis. That's it, which I can see. So I'm going to go second trace, number 2. I'm going to move my cursor to the left side of that x-intercept, which is where y is positive. So because I can't see that value, I'm just going to look at where y is positive, and that's all that really matters. There, right there. That's the left bound. Press enter, and then where y is negative, that's my right bound. Press enter, and then enter again. You should get that the 0 is -16. So to show your work, what I'm doing is I'm writing the window that I used. So my x window was -20 to 20, going up by 1. My y window was -10, +10, and 1. I found one x-intercept was -16 by going second trace, number 2. And then the second x-intercept, I'm going to do that same step again, second trace, number 2. Move to the left side, that's the left bound, which is where y is negative. Press enter. And if you move your cursor to the right, you're going to make y positive, which is your right bound. Press enter and enter again, and you should get that the 0 is 14. Now, that means that there are 2 sets of solutions. If x is -16, that means if we add 2, remember our x plus 2, this is our x. If we add 2 to that, we're going to get our next even integer. So if you guys look, if you multiply these answers, they will give you 224, positive 224. So this set of solutions work. Now let's look at this one. If I have 14 as my x plus 2, meaning add 2 to that number and you get 16. This is another set of solutions that if you multiply them, the product, you get 224. So you would have to have both sets of these to get the full marks for this question. Okay, so that would be your lesson 4.1. So what you want to do is make sure that you try your day 7 homework. So I'm just going to scroll up just to show you. Where are you? Day 7 homework. So that would be this homework right here. Try some questions just to feel confident with how to graph it in your calculator. So make sure that you guys practice these. Okay, so I hope you guys understood everything. Ask me questions if you're not understanding a certain concept or if you're having trouble with your window.